afternoon, everyone. Thank you, Ms. Nakajima. Okay, everybody's been watching television, so most of the details of the earthquake and the tsunami and the meltdown are already known to you. So anytime we approach a lecture, we always go for who, what, when, where, and why, the 5 W's. You guys already know who, what, when, where. I'm going to concentrate on the why. Why did the earthquake happen? The earthquake which caused the tsunami, which caused Fukushima to melt down with plutonium and uranium. Plutonium and uranium are extremely strong chemicals. They're elements. They're way down on the periodic table. But recently, we've started to understand that the periodic table, which you all learned in high school, and the 100 or so elements in it, is really just the beginning. The elements that are used in the universe are much, much larger. These elements are almost nothing in the universe. We use them here on the surface of the Earth, but the surface of the Earth is very, very small. We're way over here on the tiny bit of edge of a small planet, not even a very big planet. But it's one of those rare planets that allows people to live on it. When the earthquake hit, all it moved was about 500 kilometers and dropped at about 7 meters. But that's a huge amount of water. That's about 4 times the size of Kokubunji. Just whoop, and then jumped. And all the water had to go someplace. It headed straight for Fukushima. This was in Japanese Newton magazine, and it really shows that wave coming ashore. Normally the wave's just out here on the beach, and this is only just the beginning as it came ashore. It really, really came in up to 10 kilometers. But when we look at that from the sky, the satellites picked up before, and this tiny little change was the whole tsunami. Didn't look like much from the sky. But boy, if you're trying to run away from a wave that's 4 stories tall, you better be running fast. The tsunami, as you've heard, the tsunami is not that bad. It's what it picks up. It picks up trains, it picks up cars, it picks up the whole building and brings it along. So you're not trying to swim. You have no choice. You're just tumbled around like sand. And it's very, very unusual for anyone to survive that. So after the tsunami came and went, Fukushima did very well. It did amazingly well to be hit by a 9.0 earthquake. There's only a few earthquakes anywhere that have ever been stronger. The biggest earthquake was 9.5 in Chile, and that's almost 2 times the size of our earthquake. So the huge Chilean earthquake about 15, 20 years ago was double the size of ours. So the Fukushima power plant, I think you all know the shape. It's essentially a big bottle. It has a big round bottom and a tall part up above. The fuel rods sit up above, and they look at each other and they throw neutrons back and forth and heat each other up. By themselves, they don't do much. When you bring them together, then they cause a lot of heat. So the engineer said, okay, if there's an emergency, turns off. But uranium and plutonium do not turn off. You can slow them down, but you can't stop them. So they continue to make heat. And when the water dropped, because the tsunami took out the electrical generators, the water came down. So when these got exposed, there was nothing to keep them cool. They melted. And when they melt, they just kind of fall apart, and they come down to the bottom of the big bottle. That's what they're supposed to do. For about a couple hours, the ones that stay cool even better. The ones that are on the bottom, there's not so much. You're trying to spread out that uranium and plutonium as much as you can. But we were hours and hours and days, and still no water. So the plutonium and the uranium collected on the bottom of the bottle and eventually melted through that's 15 centimeters of stainless steel. Now, stainless steel is really tough stuff, and this is the best of the stainless steels. So it built up enough heat not to explode, but it's next to each other, so it's getting very, very hot and eventually melts through. Again, good engineering. Some of the rods are still up here. Some of the plutonium has melted down to the bottom, and now it has melted through into the next layer of water, a big pond of water. So that it melted through, it left some of the uranium and plutonium here, some up here. Now 1/3 is down on the bottom. So they're spreading it out. And as you spread it out, it doesn't interact so much. It cools itself down. If it gets worse than here, if all of it came down, then there's side areas where it falls off into more water. The whole idea, spread it out as much as possible. Then it's not so dangerous. So we have seen them doing a very good job. Politicians got involved, that slowed everything down, but the engineers were trying very, very hard because they knew what to do, and they were doing their best to do it. I am very, very pleased to see the Japanese, especially the older gentlemen, the guys that have retired, they're up in their 60s, and when the radio said, this is not so dangerous for older people, but it's very dangerous for young people, the old men stood up and said, we're ready. 270 men got together and went down to the Capitol, and they said, we're ready to go. Send us in. We're too old to be bothered by the cancer. We'll help. And the government, and they didn't say yes. But Japanese men stayed, and they organized. And when it came up to say something again, they were right there. And they said, hey, you need a lot of people. You need them there. We're ready to go. No money. Free. We just want to help. That shows a lot of respect to the country and to the people. That's very good. When the world sees that, they say, wow, that's impressive. The only other time I've seen something like that was when a huge tornado came through the Mormon section of Utah. It clobbered the whole area. But the religious people of that area came together, and in 2 weeks they fixed everything. They just came together and boom, in 2 weeks they said, we don't need your money, we don't need your help. Boom, they fixed it. Japan is doing just the same thing. The people are there. They say, you need money? Boom, here's our money. You need clothes? Buy the truckload. People were donating cars, money, futons, everything they could think of, to the point where there was too much. So now, what they're really in need of is a bank to help them start up again. The big banks have too many rules and regulations. What would really be nice is to see some of the older folks that have been in banking get together and say, instead of just donations, let's have a bank. People can donate to the bank, and the bank will get a very low rate to the people in Fukushima area that need to rebuild, so that the banks are not saying, thank you very much. It can be a bank, and it can receive some interest, but reasonable. And they can help a lot. I'd like to see that. So if you know any good banking people, ladies and gentlemen, talk to them. Okay. That brings us pretty much up to date. It was a major earthquake. We have now had more than 1,300 additional earthquakes, up and down, mostly above. Unfortunately, the real problem part is right offshore Tokyo, where there's 2 huge earthquakes waiting to happen. This is 1 month after the earthquake. This is 45 earthquakes this particular week. Same location. This area relieves some stress. But right in here, the only big earthquake we've had was in Kobe. What was that, almost 15 years ago for the Kobe earthquake. So here and down here, we have huge earthquakes waiting to happen. And if a big earthquake hits in this area, Tokyo's sitting there looking at four flights of stairs of water coming inland. That's not when I want to be on one of those subways, because you're going to have to move and move fast. I really got interested in this type of thing because I was studying physics, but I was going the other way. I was starting with light and with atoms, and I said, when they get inside the planet, what happens? And that's when I started thinking, if I had a pizza, and here's a young gentleman with a nice big pizza. This happens to be a picture of the sun. But if I cut a pizza piece out of the sun or out of any large planet, and I drop an atom down there, eventually it's going to come to a point where it can't go any further, it's just too big. But the atoms have different parts. They have the electrons on the outside and the nucleus on the inside. There's a lot of space there. So as it gets further down, the electrons say it's getting a little crowded, and some of them start to drop off. So as you go into a planet, there it is. Big red dot. There it is. Okay. So as you go down into a planet, it starts getting very, very high pressure. And the high pressure is fine. The atoms don't really care, but the electrons start getting busy. There's no space for them. So they start staying back. It's easier to be an electron on the surface than it is to be an electron down below, because you're getting pushed from all sides. So what's happening is the atoms start becoming positive ions. That means less and less electrons. So all your electrons are kind of towards the outer edge, which makes sense. We got the aurora borealis. We see the electrons in action all the time, all the lightning. All the electrons are hovering around us in our normal life. Doesn't bother us. But oddly enough, it's those electrons that are actually causing the gravity that you feel. As you go deeper in, less and less electrons are there, and more just protons and neutrons. So you're getting a monopole. You're getting just positive. So the closer you go to the center, the less electrons, just positive protons and neutrons which are neutral. So all the positive protons are saying, hey, we like electrons. Where are they? They're on the surface. So the protons are pulling on all the electrons all around the planet and saying, stay close. But the electrons are saying, we'd like to, but it's too crowded. So the hardest thing to understand was I had to take Newton's ideas of gravity and throw them out. I had to throw them out. And I realized that gravity is only in large objects. When you have a monopole starting to set up, it seems to be about the size of the moon. You start getting enough pressure that the electrons can't stay. They head on the outside. So the center of the planets, the center of the stars, are mostly protons and neutrons. So they have a huge gravity because they're looking for the electrons that are part of your body. And that's really why you stay here. If you were all positive, you'd float off. And we actually see that happen. We actually see that happen when we look at a large star. This is only planet Earth. And this gentleman, in his nice 6th grade drawing, has a star, the sun, and he's pointing to the Earth. The Earth, you need 109 Earths to go across the sun. They finally, about 10 years ago, gave up on the idea that the sun is hydrogen turning into helium. They said, it just didn't work. It sounded cool, but it's not happening. The sun is quite solid, very, very solid. So is the Earth, and so is the center of the Milky Way galaxy. It's now becoming more and more evident that the sun originally came from the center of the galaxy. And the nice spiral arms that we see on the galaxy, here's our wonderful sun, there's the center of the galaxy. We're about 2/3 of the way to the edge. But we came from the center originally. Not as a sun, we came out of the center as a quasar. What happens is at some point, now we're going to use this one as the center of the galaxy. At some point, the protons start pushing apart from each other so much, and the neutrons are happy to go together. So the protons break off from the neutrons, and you get a bubble of protons. Because they're all pushing apart, they are not as dense, and they float like a bubble. They float amongst very, very heavy material, but still, they're pushing up, everything else wants to go down, and they come shooting out as a huge bubble. How huge surprised me. It wasn't until about a month ago. I found out about this class about 2 months ago, and I have learned more in the past 2 months than I had in 2 years because I was intense and I was looking. And some of the European astronomers saw a quasar coming out of the Milky Way central part of the galaxy. And the quasar came out, and then it went kaboom. 50,000 stars came out of that one quasar. So it came out of the center of the galactic core, but as soon as it came out, it was no longer under pressure. So it started to decompress. It started to expand. And when it came apart in 50,000 stars. Now those are early stars, so they're still very, very proton positive. They collect up electrons, neutrons, all kinds of things as it comes out of the edge, outer surface of the galactic core, and comes out and then explodes, and each of the stars takes off in its own direction. Those that are headed back collapse back into the center, some go out. I was surprised because I thought the sun would have come directly out of the center of the galaxy. When I found out that it is a secondary process where it comes off of a quasar, that made more sense because we're not a straight line moving away from the center of the galaxy. We're on a kind of off to the side course, and that explained it. We came out and then we went off to the side. We didn't happen to be one of the ones that went straight out. But the nice circular radial arms is happening because the same area that gives off the first quasar gives off a series of quasars. And the center is turning. And we're finding that the quasars tend to come out the two sides, which, when you stop and think about it, starts to make sense. Because something large, like 50,000 suns coming out of anything, is going to set up a shock wave. So the quasar comes out, it's leaving, but it leaves behind a gap that comes together, goes bang, and the shock comes around the center of the galaxy and hits on the other side and causes a second reaction, which starts another proton ball or quasar headed out. When that one leaves, it bounces back around and hits itself again, and you get this repeating motion. So you're getting quasars coming out both sides on very regular intervals, and it sets up these beautiful rings because they're going straight out, straight. There's no reason for them to curve, but the center is turning. So it goes bang, 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 bang. And this one's gone for 5 years, this one's gone for 3 years, this one's gone for 1 year, and you get this curve, the beautiful curve of the galaxies. So we've kind of figured out how this is finally working. So my part said, okay, come on back. How does this help us? Well, it tells us that we really are using very small things, uranium and plutonium. These 7 lines are all we can make at the moment. The names start getting ridiculous. Octobian. Strange. Hydrogen, helium, everybody had nice names. They started running out of names. They're starting to give them names. But I said, okay, let's go. This is the surface of the planet. And we find that when we add neutrons, we can make uranium into plutonium. I said, oh, that's interesting. And I started digging that direction. And I said, okay, how many neutrons can you put on? And I found that they already knew. This is one long table, one on top of another, starting with hydrogen and going all the way up into the uranium range. And I looked at that and I said, wow, that's pretty impressive. I had never seen that before. This is a chart of the nucleotoids, which is the same elements with more neutrons. Sounds good. But this confused me. I said, well, we have these on the surface of the planet, but these need more pressure to even exist. So I looked at this and I said, Chotto matte. This looks cool, but it's upside down. So I turned it over and I said, here's hydrogen, floats around, nice and light. But as you get heavier, they had this strange spot where it kind of broke apart. And all the elements are here. And then we get down to uranium and plutonium, and they're past this gap. And they're saying, well, what's that? And I said, gee, that's the surface of the Earth. You need higher pressures to maintain yourself as plutonium, uranium, and all the big elements. So really, the center of the planet starts here. As you go deeper, yes, you can have bigger and bigger atoms. No, not much in the way of electrons, but you can start getting huge atoms. So those atoms, without their electrons, don't give off light. Light is only the play of the electrons going closer and further away from the center of the nucleus. So if you don't have light, it's dark, i.e., your dark matter that everyone's been talking about and they say is everywhere is really right below your feet. It's in the middle of the planets, it's in the middle of the stars, and there's a lot of it in the middle of the galaxies. So we've answered the higher density. We've answered that gravity is not really just a particle that everything has. It's just a balance of the electrons looking for the protons, protons trying to hang on to the electrons, but it gets too crowded. So that's gravity. Then we went to dark material, dark matter. It's there. It's everywhere around us, yes. Where is it? Inside, because there's no electrons. It's dark. Good name. Didn't really mean that to begin with, but it works out. The other one they had was dark energy. This one really threw them. They said, for these things to be happening, we need a tremendous amount of energy that we can't account for. And these gentlemen, a couple of physicists, good old physicists, nothing better to do, they started playing around with quarks. And a quark, as far as I know, is a little round guy. For convenience sake, we're going to use some magnets. And they found that neutrons are 3 quarks together. And everyone had been thinking of neutrons and protons as being spheres, as being the shape of a ball. It's 3 pieces. anything 3, be it golf balls, magnets, anything 3, is not round. It's flat. It has a triangular shape, and they go together. I can't show the colors here, but they like to sit in a certain sequence. They only line up this way. This way they don't go, well, this way they go together. But you turn them a little bit the other way, and they don't. And it turns out that they like to sit this way and on top of each other. And these gentlemen, in the past about 5 years, have really turned the whole physics of the inside of the atom on its ear. And they started putting these together bigger and bigger. There's a nice picture of it. And it came up into all kinds of shapes. And the shapes started making sense. When the barium rings finish, it's nice and stable. You add one more, it throws everything out of shape. And it starts reacting with other chemicals much more easily. This one I recommend to everyone on the web. It's unclear to nuclear. Unclear to nuclear. Wonderful article. These guys have really done some fantastic work. And you can actually see what the inside of a nucleus of an atom looks like. So these gentlemen are merrily building the atom from the inside out, explaining why it works. And they found out that we have nuclear fission and we have nuclear fusion. And they found out that fission is not making all the energy. The fission is the breaking apart of two pieces. But they discovered that what's left collapses in on itself. And that is where the tremendous energy is coming from. It's the refusioning of the two parts that give off this tremendous amount of energy. It's not the breaking apart. It didn't make any sense to them, and they looked at it and said, oh, that's nothing. Here's the huge energy. So the fusion reactions, the actual collapsing of the parts back together again, are what give us our huge, atomic bomb heat. Okay. So, let's see, I've gone through just about all of our parts here. Coming back to what we can do. At Fukushima, we had a tremendous loss of life, about 25 to 28,000 people, which is 1/10 of the people that were lost in Indonesia. Almost 250,000 people gone in a day. That's 250,000. Kokubunji is 130,000. So double the population of Kokubunji disappeared in one day. So we've lost 28,000 people. The people of Japan have come back together to help those that survived. Now, as engineers, we look at Fukushima and we look at the nuclear power plants and we say, we built almost 7 meters high wall to protect these atomic reactors. Phew, right over the top. Got to build it better. Now that everything around those reactors is poisoned, it can be cleaned up. I suspect that Japan will rebuild better reactors at those locations. Engineers of Japan are amazing. I mean, there's so many of them that, a class is almost 30% engineers. And those engineers are fighting together to be the best. So you have engineers galore, and you have retired engineers that want to get back in. Go for it. Talk to each other. Hand in some ideas. You may or may not get paid for it, but hey, you're sitting around. Retired engineers are very frustrated people. I know, I am one. So look at your layout. Give it some thought. Japan needs nuclear power. Oil is running out. That's why America is running around killing everybody to get at the oil in the Caspian Sea. If you look at all the wars that America's playing with, they're just after the oil. They give Libya to the French because they don't want to be too obvious about it. When the oil runs out, you better be ready, because there's nothing left to burn. We have a wonderful start. We have nuclear power plants. We can build them better. If they're done correctly, they can run very nicely. Personally, I had an idea, the leftover metals that get contaminated, what in the world do you do with them? They're not terribly radioactive, but they're a little bit nasty. And I thought, gee, how about making them into train rails as you go up into the snow country? There's nobody up there. Keeps the train track a little bit warm, and it's out of the way. So if you have any steel gentlemen, maybe you can ask your cohorts if the spent uranium and the contaminated steel can be made into train tracks far out of town where there's nobody around. You have to be careful putting them in, but they're going to be there for 100 years, which is about what you need for these things to be safe. Okay. Got a long way to go. Let's go ahead and start early with some questions, and we'll take it on in from there. Gentlemen, ladies. Now, what did he say in Japanese?
ちょっとなんか見て要約するぐらい日本語で。
それはちょっとできません。
難しすぎてね。
でも
あなたいやまあ。
Let's now Mrs. Nakajima is a physicist. Doesn't look like a physicist.
ちょっと物理のことがよくわからないので、物理のことがよくわかる方がいらしたら説明していただけるとありがたいんですけど、日本語で。
誰か見かけの方がね、反対したい。
Hi.
You talk about two issues.
Go ahead.
One is surely talk about Fukushima disasters in Tokyo area. And the other issue is about atoms.
Yes.
You talk about dark matter.
Yes.
The dark matter is very unpopular for us.
Why? Just for the people or for the people of Japan?
Yes.
The Japanese are not interested?
Okay, but you talk about a very detail of the nuclear.
Because that is where your earthquake is coming from.
Yes, I see. The reason you explain about the atom dark matter is a cause of the earthquake.
Okay, perfect. See, I could have paid him to do that, but I was hoping someone would ask just that question. And that leads us into our movie. So the next part is how all that comes back to an earthquake is coming up. Go ahead.
I'll give you one comment. That explanation is not open or talk about in the Japanese media.
Correct.
So that's why we are a little bit embarrassed.
Don't be embarrassed. When I was reading this, like I said, I didn't find this information, the nuclide charts, until last month. And I study this stuff all the time. It's just, I started wandering around through Google, and I found this, and I thought, oh, that's interesting. And 3 or 4 steps later, I came on this, and I came on these gentlemen. There's nothing, remember the media is talking to everybody. And some people are cooking, some people are playing mahjong, some people are playing shogi. They're not really interested in this. The media is there to tell you every day it's raining. Yeah, you know that. Sometimes we have programs. Now I'm going to get in trouble. A few years ago, Japan got really angry at the bosses of TV. And they dug in and they found out that there's like 5 men running everything on every television in Japan. And they said, what do you mean you own every television? Well, we own this one. Yeah, well, he owns that and he owns that, and everything comes together to these guys. So you're listening every day to what 5 men tell you to watch. It's up to you. They all stood up and they said, oh, go minasai, and they went right ahead, did it again. Okay? But that's your country. I don't watch TV here. I have 700 movies I brought with me. I watch the internet. I enjoy it. There is so much information here. I mean, even last night, I knew I had to get these printed and laminated and ready to go, but it was just too interesting. I'm wandering off this way and I'm wandering off that way. Tremendous amount of interesting information. But you have to use your minds to say, oh, that one goes with that one. And you bring it all together. And that's what your brain's all about. You can see a tremendous amount. It's there, but you have to find it. And you have to say, where does it go? How does it tie back in? So all these, I made up this chart here. I just said, okay, here's the usual atoms. I start getting rid of the electrons as we get deeper and deeper. The electrons are all gone, then it's just protons fighting against each other. What happens when you run out of the protons? So you end up with a layer with electrons, without electrons, with protons, and then you start getting down into just neutrons. But it would all lay out in a big chart. So I drew it. Doesn't mean a whole lot, but just to give you the feel that what we deal with on the surface of Earth is very unusual and not very dangerous. There's a huge amount of energy and power available if somebody knows how to do this. I don't think humans would be, you're looking at tens of thousands of years to get to the point where these are used. But again, it's fun to look at from my point of view. Now, the movie I'm going to show you is very, very popular on the web, and it's also hated by many of the older geologists because they like plate tectonics. They say that the Earth is on about 9 or 13 big plates that are wandering around. The movie I'm going to show you is called Expanding Earth, and it's going to show you that Japan was touching right here. This came together, and the whole hard pieces slowly go back together in time, and they form a perfect ball. Everything works together about 95 million years ago. And I take it even one step further. I say, if you go back further, even these will start coming together even to a smaller ball, to the point where we came out of the sun, just like Mercury, just like Venus, Earth, Mars. Each one came out of the sun slowly, one after another. It may be interesting if we see the next one come out. That'll be quite an event. If the next planet comes out of the sun, it'll be moshiroi. Might be deadly, but it would be interesting. So the movie I'm going to show you is the big Pacific and the Atlantic. There's little lines, and they went down. I said, how old is this? How old is this? How old is this? And then they went backwards, and they say, okay, everything this age, push it back in, and everything came together perfectly. And I saw that, and I said, wow, that's what I was looking for, but I was going the other direction. I was going into the Earth, making things denser, and it turns out that the Earth is decompressing. The Earth is slowly getting bigger, not gaining mass, just gaining volume, because the big pieces are breaking into two smaller pieces, and each one needs a little more room. But each of those pieces is an atom of all of this. That's a tremendous number of atoms. So each one just separates sometime, but there's that many atoms to do it with. So it's slowly getting larger. It's not gaining in mass, it's just gaining in volume. It's becoming less dense, it's decompressing. Okay, so let's watch the movie, and then you can holler at me and get angry all you want. Mark Twain said, the doors open at 8, the fight starts at 8:10. So let's see if we can do the movie. Yes, I think it's so big it'll maybe show up on the wall. Let's go ahead and close the lights and see if we can see it. Christy, can you close the blinds? This might work. Oh, not bad. Okay. Let's see. There we go.
We come to the Earth, which, well, grew to get here, the way it is now. Here is our world, our planet Earth, floating in space. We will be going backward in time, imperfectly, but done in a very disciplined manner. Please notice there is no subduction, no rotation of tectonic plates, no twisting, no form-fitting, no altering shapes or sizes. It would be impossible for these continental plates to fit together perfectly without this being true, and yet the upper tectonic plates fit together perfectly on a much smaller planet. Yes, there's been some erosion, landslides, blah blah, but overall this activity is insignificant. There is a kind of conspiracy of silence among certain scientists. They know but are not telling you that the upper tectonic plates of Earth also join in the Pacific. Not partially, they join totally. You are asked to believe that the continents swim or drift about willy-nilly, bumping and crashing as if they were on a greased skillet. This is not true. The simple truth is apparently too upsetting to too many apple carts. We're now going forward in time to show how the actual growth of the Earth took place. Imperfect as to details, but the overall is nailed. Antarctica, as you see, has become subtropical. Africa on a smaller globe moved way downward under the globe. In fact, for hundreds of millions of years, the bottom of Africa was the South Pole. South America's tail goes under and wraps around the bottom of Africa. Then incredibly, it joins coast with Antarctica. 65 million years ago and more, these continents were joined, and marsupials like the duck-billed platypus roamed from Australia, Antarctica, and across southern South America and up into Africa. The platypus. Dinosaurs roamed all over this world on the upper tectonic plate because there were no oceans, just shallow seas. Here today, Antarctica is frozen over, and Australia and its surrounding islands are the remaining home of marsupials. Do you see how broadly the Pacific is opening compared to the Atlantic? This is exactly why the knee-jerk Pangea theory exists. The Pacific spread is too difficult to easily visualize because it's so big. The Atlantic spread is so obvious that a child would recognize it, but they are the same. Check this map out. The Navy and others took core samples to find the ages of the sea bottom. Lo and behold, no part of the undersea was found to be much older than 70 million years old. Does that shock you? It should. It shocked the scientists. Where did they get ancient fish fossils from? From the land, like in Mississippi and Utah and France and China. Most of the undersea wasn't there 70 or 80 million years ago. The measurements of the core samples give the age of the sea floor. Newest, 10 million or so, is red. As we go back in time, we go backward in our rainbow, orange, yellow, green, blue, okay? So we bury the new sea floor back to the fault lines as dictated by color or age. 10 million years back, these are the ages of the seafloor as measured by science, and they're generally true. Earth grew. 20 million? I'm not making this information up. This map comes from the scientific community. 30 million. You can find the same map in many places on the internet. It's common knowledge. 40. The ocean bottom is from 1 year to 180 million years old. 50. 70% of it is no older than 60 million years old. 60. The upper plate, the continents, are as old as 2 billion years old and more. 70. 10 to 20 times as old as the undersea plates. The undersea plate is new and spreading at the rifts. Why does the scientific community desperately cling to and promote the idea that the ocean bottom is sliding under the continents and into a magma which is twice as dense as solid granite? A totally unsupportable and scientifically unsound idea? They have to. Or else they'd have to observe and admit that the Earth is growing. And that, viewers, is a very big deal. That would change everything in science, from the smallest particle to the whole universe. 100 years of scientific theory out the window. That's a lot to give up. It's important to remember that science and the universe should and must be easier to understand as we go back in the universe's evolution. This is an undersea map. As a kind of test for ourselves, we deemed it important to show that not only the upper plate had to fit properly together, but the undersea had to spread in a logical, reasonable pattern that we could see and understand as rational humans. Do you see those lines in the undersea which, beyond information, show direction? The direction of movement apart and away from the rifts. In fact, it's like a movement diagram, isn't it? We're moving now. Let me point out that the newer undersea near the rifts is smoother and more regular than the older land further away from the rifts. Here in the Atlantic, the rift goes right up the middle. Half of the Earth's growth has happened since the extinction of dinosaurs. This means that the Earth is accelerating in its growth. In the last 65 million years, Earth nearly doubled in size. The last redoubling took 600 million years, at least. We're continuing all the indicated undersea directions like following a blueprint. The Earth guides us. And now the land masses will come together perfectly. As we now go forward in time from 185 million years ago, please notice there is no subduction, no raising and lowering of land masses. There can't be. It's hell in the form of magma down there. Local raising and lowering, yes, but not on a massive basis. It can't happen. There's no turning, rotating of land masses. The land masses sit in their individual plates and don't move. The rifts open, that's all. For examination, I'm going to run a few vignettes of each area of Earth that you have a right to be curious about. The North Pole. Man, I love this map so much. There was a piece in the recent National Geo. It shows that the trees in Asia and North America were exactly the same trees. Well, this is why. The land was together when the trees evolved. The South Pole. The oceans have absolutely nothing to do with tectonic spreading, except that they cool the thickening mantle. Tectonic spreading, even according to the most conservative scientists, has created 2/3 of the Earth's surface in the last 200 million years. And therefore, the same must be true on all planets, including Mars. Must. And we can see the younger spreads on Mars just as on Earth. But there is, just as clearly, no subduction on Mars. It can't be both ways. You either have spreading and subduction, or you have only spreading, and you must have spreading. Or you can continue to ignore the facts and say, as the ancients said, that the Earth is unique and singular in the universe, and that we are the center, and the universe rotates around the Earth.
Yes, please. I was wondering how old Japan was. Because we're sitting on a huge cliff going down into the very, very deep trench just off our coast, I was kind of worried. But I was over at Goshogaku and I saw a strange rock out in front and it had a little poster. And I was looking at this and I said, that's Kino Kaseki. I said, what's this? So one of the ladies came over and she read it. Turns out one of my daughter's ancestors found this up in the mountains. Kino Kaseki, trees that have turned into stone, take about 30 million years to turn from wood into rock. Japan, as we've seen in this movie, really isn't going anywhere. We're on the very edge, and yes, we may have a little bit fall off into the abyss, if you will. But really, Japan's been here for a tremendously long time. Don't expect it to disappear next week. So for that part, you can relax. You do have some concern, that huge earthquake that's building up off of Tokyo. That line is pointed directly to Mount Fuji. See that nice yellow spot? The first yellow one? Mount Fuji. So this one, they don't draw it, but I see a nice line coming straight through here, and all this pressure as it pushes apart. These are small things compared to what we just saw, but small things to us can be very dangerous. Mount Fuji last went off, what, about 800 years ago? Something like that? Not that terribly long ago. Blew out the side that time. So keep an eye on Mount Fuji. If you start seeing smoke, remember that most of the land that you live on comes from Mount Fuji. So dust masks, I don't know if it's going to help much. This one last one that I'll show you. This is the tsunami as it went across the ocean. Let's see. There we are. Here's little old Japan, and our tsunami went all the way down to South America. So it was a nice wave. Fortunately for the rest of the world, they didn't get hurt so bad. Only a couple of really stupid people were out taking photographs as the wave came, and they got taken out. You want to be stupid, you get hurt. The people of Japan tried their best to get out of the way. They're learning now that a nice straight road with nothing in the way is very nice if you have a bicycle and you can go like crazy, because that wave's coming in at around 600 to 700 miles an hour. That's a Shinkansen chasing you. You don't have much time. When that alarm goes off, start walking. You might have to walk back if there's something to walk back to. If you got a bicycle, go by bicycle. Cars are too big. Grab your kids, grab your grandma, and go. Yeah. Kokubunji, we're up 75 meters. Not bad. That means all of Tokyo disappears and we become the new shoreline. But we're let's see, an hour by train, so we're about 60 kilometers from the shore. We're in pretty good shape. Now, Kokubunji was the shoreline. Everything else was swamp. All of Tokyo was a big swamp. There wasn't much going on there. Now it's all built up. That means it's all sitting on soft sand. And when an earthquake goes like this, the sand goes bleh, and everything goes bleh. So Kokubunji's a nice place. I like it. No, my wife's family has been here for 14 generations. I don't know, somebody knew what they were doing. They had a good idea, so the more I look at Kokubunji, the happier I am to be here. It's quite nice. Okay, ladies and gentlemen, questions? now that I've gotten even more. Want to start us off? Go ahead.
May I ask a favor?
Sure.
Thank you very much for your good lecturing for us.
Thank you.
And I respect your long time stay in Japan and your deep knowledge about disaster, So I would like to propose one thing. Please, I would like to need your opinion. Because I went to the United States
Yes.
May 9 to 21. I attendance for my society. It's, SKIP, do you know SKIP? Society of Competitive Intelligence Professionals.
Okay.
61 countries, 3,000 members. Only Japan people is 47.
Okay.
I'm a delegate of Japan.
Right.
So everybody, almost everybody asked to me, how about Japan? Big earthquake, So I went to New Orleans
Yes.
and I find the school buses. There is school buses in the United States.
Yes.
But 2006 come to Hurricane Katrina, and they tried to shelter to another way.
Okay.
So they used to school buses. In Japan, no school buses. This time in Fukushima too, there is no car, no buses, no gas, If you have the school buses in Japan, more quick move to other place. How do you think about school buses? And I'd like to say your country. Thank you very much for the assistance to Japan, especially aircraft carrier came to Japan. It's with 25,000 soldiers and Z-Bob come to Yokohama. Z-Bob, very important special team.
Oh.
Z-Bob is only 3 times, only 3 times. So there is an Atlanta Olympic and Denver Summit, and this time I'm appreciated for your country assistance to Japan. Thank you very much.
I am a non-military person. I find plenty of things interesting on this planet rather than blowing each other up. It makes no sense to me. We only live on a tiny, tiny fraction of this big place. There's plenty of room. There's plenty of things to do. There's no reason to be hurting each other. I don't like the military. I think a military system should be something like a massive Red Cross. When there's an emergency, they come, not to attack, but to help. That's what I'd like to see. Now, the only way the Americans justify all this, that's a different lecture for a different day. I am a non-military person. I was in the U.S. Navy. I didn't like it. I didn't like what I saw. I was a hospital corpsman. I saw disease. I saw just nastiness. So I don't like the military. I don't think it's a good idea. I am very happy that Japan has managed to stay out of that stupidity. Japan has a very strong people. If you had to arm yourself, I imagine you could within a few months. But that's a different story, a different day. Get me started on that, I'll be here for a while. Go ahead.
So I'm very sorry that I'm not an academic person.
It's okay. Neither is the guy who made this movie. He's a cartoon actor. The man who made this movie does cartoons. He makes cartoons, but he used his professional ability to put it all together. He took everyone's information and put it together. So go.
And that is a kind of stupid question.
There is no such thing.
Yeah, if the situation gets worse.
Here?
Fukushima?
Fukushima?
About Fukushima issue. And or very sensitive or dangerous. And I think maybe the military doesn't change the program. And what source is very reliable?
Okay, your best source is the internet. America is currently trying to turn off the internet. They have laws they are now trying to start saying if they feel it's an emergency, they can turn off the internet in the United States. Gets me angry. They also have decided that any books older than 1960 have a tiny bit of mercury, so they're getting rid of all the old books. I don't like that either. In answer to your question, how dangerous is it if the radiation from Fukushima gets up here to Tokyo? How many atomic bombs has America dropped, has America exploded in the United States? How many bombs has America exploded in the air in the United States? Same as Hiroshima, same as Nagasaki. Not my. 243. I don't have it with me. It's on the projector. They have blown up so much atomic material in Nevada that the radiation has covered the whole farmland of the United States for the past 50 years. I didn't know it until I started searching all this, and I said, I've been eating that my whole life. So really the little bit that we have in Fukushima is not likely to kill much of anybody. It might catch one or two people, but it's going to be very unusual. To get you sick, you have to collect enough atomic material in your body to start causing trouble. Now there's a picture of a body here somewhere. There he is. The biggest one is iodine. When uranium and plutonium go through their list of chemicals, starts off as uranium and plutonium and breaks down about 13 times and about 12 times. And each time it becomes a different atom. It becomes smaller, 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 just like we were saying as to why the Earth is expanding. This is happening right now. So you don't have plutonium. A couple days later you have cerium and strontium. And both cerium and strontium are nasty chemicals. They don't kill you with the radiation. They kill you because they act like potassium, which you eat in bananas. So your thyroid collects iodine from nori. That's why we are so healthy in Japan, is we have good sources of iodine. It keeps us healthy. Radioactive iodine goes to the same place. Your body says, oh, iodine, thank you very much. Sticks it in your throat. And your thyroid, which is right here, controls the rest of your body. It tells you to grow. It tells you to go fast. It does many, many things. Let's see. I'll just quickly read it. Increased metabolism, growth and development, increased, I can't even read it. I don't know what it means anyway. So it affects the hormones of your body. The older you are, the less problem. Little kids, and my daughter is already 12, so I'm not quite as worried. But babies, it stays there. Some of it gets washed out. But cesium and strontium, especially strontium, likes to find your bones. It acts like calcium. And it goes and it sits in your bones and it will stay there. And it won't come out. It's very, very difficult to get it out of your body. Can you do anything about it? Not much. It's invisible. It could be sitting here on the wall. You could be sitting on it. No way to tell. If you have a Geiger counter, and I think I've seen tiny Geiger counters starting to show up. Wouldn't be bad to have one. There might be Ichiman. Just keep it in your pocket, thing starts vibrating, something's wrong. So it wouldn't be bad to have. But as far as the radiation from Fukushima killing you in Tokyo, not much chance. Not much chance. Number one, it's spread out 200 kilometers before it gets here. Number two, you have to be the particular one that has that cup of kocha that has that chemical in it. It's pretty washed down. And remember, it's trying to fall apart as it goes. Cesium, strontium lasts a long time. Iodine, 8 to 13 days. So it's in half. So 4 days later, there's almost nothing. Okay? So if you hear an alert, stay away. You hear that there's iodine going on someplace? Stay away. Because there's not only iodine, there's cesium and strontium there too. And lots of other nasty chemicals. So if there's a problem, stay away. Give it a few days. It's heavy. Strontium and cesium, pretty heavy. They like to fall down, they get on the ground, they get washed out into the ocean. Give it a chance. Fukushima, they're trying real hard. Just let them keep doing what they're doing. And when they build it, when they rebuild their reactors, you have 53 reactors in Japan, encourage them to do really nice ones. Spend a little extra money. It all comes back. It's still inside Japan. It's Japanese companies building these things. It's better than watching the government throw it away. Let them build something really nice, something that's going to last, and something is really, really smart. And you older guys, watch them. Don't let them build mazui structures. If they're going to build a nuclear reactor, make it a good one. Watch them. And if you don't like it, say something. You're the bosses. You are the elite. You are the brains of this whole country. 65 and older. You guys have been here. You've seen everything. Don't let them say, hey, you're 65, go away. Speak up. You're citizens. You can say, hey, this is my Japan. This is my Kodomo. This is my grandchildren. I think you're doing this wrong. You should do it better. Okay? It's your country. Go for it. It's been here for more than 30 million years that I know of. It'll be here a lot longer. It's a great place. Got plenty of water. It rains. All that bad stuff goes down into the trench. Adios. Bye-bye. Don't worry about it. Go ahead. Louder.
This might be a simple question.
I love simple questions. They're easy to answer.
You said that Mount Fuji might blow up.
Mount Fuji might erupt, but it's always been erupting. How many times has Mount Fuji erupted? Who knows? Come on, you guys all learned this in high school. How many times has Mount Fuji erupted?
Many times.
Simple question, simple
Long
answer.
before. Mount Fuji, volcano.
Yeah.
So, darkness.
Yeah. Yeah, if you want to see a good Mount Fuji, look down in South America. They have some really nice volcanoes going on now, and they're very dirty.
And you said that there might be an earthquake coming.
There is always an earthquake going on.
A large one in Tokyo or in Kyushu.
Yes.
But how large would you think it would be?
They were expecting the Fukushima earthquake to hit Tokyo. They are expecting that. They didn't think Fukushima was going to be above an 8.8 maximum. We went to 8 and we went to 9.0. 8.5 is what they were betting. Tokyo looks even worse. It could be a really, really big earthquake. It may not happen for 30,000 years. That's nothing for the Earth. Remember, day by day, you have earthquakes continuously happening. The one report I saw said that there's a repetition every 14 months. No one knew why. I chased it all over the place. But it seems every 14 months, there seems to be a more of an increase of just general earthquakes around the planet. We have a lot of them here because we have spreading from the land side and spreading from the ocean side are pushing together, and they crumple up, and that's what gives us our up and down a little bit. Mostly it's pushing up. So the strange report was Japan moved 2 meters towards the United States, but then the Japan Coast Guard said that the ocean area moved almost 7 meters towards China. So it crumpled and it moved up, and it moved up 7 meters and the big wave came. So can it hit Tokyo? They're calling it over 90%. The call for Fukushima came out in 2007. Tokyo has been called since 2005 for the next 30 years. So we're already at 2011. We got 20 more years of that guy's calculation. How accurate? It's a big place. You know, you can go and you can drill here, but you may miss the point over there. The more you know, the better protected you are. Can you do anything as you wander around Tokyo to protect yourself? Not really. You're too busy going about your day. Can Tokyo do anything about it? Tokyo has a lot of big buildings. That'll break up the tsunami quite a bit. It'll come up maybe 4 floors. That means taller than this building. That means if you hear the alarm, either find a nice, strong, tall building. Bricks, dame. Anything with bricks, keep away. If it's concrete and steel, much better. Thick concrete and steel, even better. So get high. If you can't run to the mountains, get it way up in a tall building. Okay? If you're in a subway, get off at the next stop. Doesn't matter. Get up the stairs. Okay? The atomic weapons that have been used to date by the United States, Russia, France, and the other countries have put a thin layer of cesium and strontium over the whole Earth, especially on the north side. They didn't do that much in the south side. There's nothing down there. So, yes, it's there. It is long-lived. Plutonium. The whole point of these is to show that the black ones last a long time. These last a very short time. So for any one particular chemical or element, some of it lasts a long time. Some of it goes very quickly, tens of seconds. So it's here. We live on top of it. Uranium comes from inside the Earth. Most of the plutonium on the surface has already changed into other chemicals. They found that if you take uranium, hit it with neutrons, you can build it back up to plutonium again, which they liked because then you can use it in reactors. So they are playing with dangerous chemicals. They're playing with dangerous energies. But that's their job. Hopefully, you teachers have taught them enough. The early men who got into this saw people die. The one guy, it's called the devil sphere. It's only about the size of maybe 15 centimeters, 20 centimeters. That's enough. 5 kilos is what they used for destroying Hiroshima. 5 kilos of uranium, and about the same amount of plutonium to destroy Hiroshima. Since then, they've been playing with huge amounts. The biggest was in Russia. I don't even remember the calculation. It was hundreds of thousands of times bigger than Hiroshima or Nagasaki. So all that stuff is floating around. Made a real beautiful mushroom cloud, but it all comes down. It's all nasty. Everybody has stopped. Korea is still playing around because they're North Korea. They'll calm down. It's not that interesting. So here in Japan, you guys are smart enough. You got hurt really bad by Hiroshima and Nagasaki, and you said, that wasn't very nice. So the little bit of atomic material you allow into your country, you keep a close watch on. Wonderful. Use it wisely. It gives you a lot of energy to do your society. I mean, we've seen just turning off a few lights, turning down the air conditioner, turn it off. It's a big difference. 2 o'clock in the afternoon, I have to try a little bit of aircon. So, teach your kids. They're the next generation. I'm already 56. My daughter is 12. It's the young kids. We had our fun. We did what we did. Now we turn it over to the next generation. There's some wonderful people there. Encourage them. Don't say, oh, we don't do that. You say, interesting idea. Tell me more. Find out. Find those young kids. There's some, this intelligence of the boys and the ladies of Japan. I'm sorry, guys, but you have been male chauvinists too long. There's a lot of female brains here that are just amazing. I teach a lot of them. The one lady out in, other than my physics student over here, there's a lady out in Ichikaichi who is astounding. She tells me about stuff. I start talking about something and she is way ahead of me. And I'm like, what do you do? Oh, I read a lot. She's amazing. And she's about 82. Just amazing. Zazen master. So she is really something. Every morning she does 2 to 3 hours of Zazen. And you can't say anything she doesn't know. I mean, she's really something. Anyway. No. I'm not kidding. No. Go ahead.
Thank you very much for your really eye-opening seminar and lecture. And there are many things that I didn't know before. So, and today I was a little bit relieved to hear your lecture that I didn't know before. And as you said just before, I think it's high time for us Japanese to think about and say war against a nuclear power plant. But I think it's only recently have I been able to think about and talk about the validity of a nuclear power plant. So if we could find only one thing, good point that comes from the March 11 earthquake, I'm not sure if I can say it's good or bad, but it's gave us a chance to talk about and think about it. And for me, actually, I was seeking for energy conservation before, but it's not for an environmental problem, but to pinch pennies, I think. Japan's under economic recession and economic uncertainty. I wanted to find out a more frugal way for myself. But now I try to think about more alternative energy that is more friendly to the environment and the earth itself. And as I said before, is it possible to construct and keep the safer nuclear power plant?
Yes. Yes. Actually, safer, yes. They have learned so much from this accident that they will use it in their next plants.
There is no possible perfect way, I think, I suppose. So that's the point.
Well, the closer you try to get to perfect, the harder it becomes. Okay? I think one of the things they're learning is their first reaction is to drop the control rods, which slows things down. What they need is a string on each one, and when the alarm goes, it takes that one that way, and that one goes the other way, and take it as far away from each other as possible, then it's not a problem. You have to break it up very, very quickly. You only have a couple hours, and there may be no one there to do it. And each one that goes its own way and gets a couple of meters away, much less dangerous. So your bottle may be more expensive, it may be bigger, but you need to get those away from each other. They're very happy by themselves. They give off so much energy. It's when a neutron hits it that they get all excited and throw off more neutrons. So you hit it with one neutron, 2 or 3 come off. So you put them together, it goes bing, bong, bing, bong, bing, 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 and you get your chain reaction. That's what gives you the wonderful heat that you use for heating the water, turning the turbines, get your electricity. You're not getting electricity directly from the fuel, you're heating water. Okay? I'm an electrical engineer. The whole point of energy is to get a lot of it in one place that you can use to do all kinds of strange, strong, amazing things. There's energy all around you. If you want to study energy from the beginning, you look up Nikola Tesla. Nikola Tesla. He's amazing. This is not Edison. This is Nikola Tesla. He developed the fluorescent lights. He developed the AC motors, all Nikola Tesla. He was the smartest man I've ever seen, smartest person I've ever seen. He started from Europe, came to America, tried to work for Edison. Edison said, oh, if you can answer this, I'll give you so much money. 2 weeks later, he came back and said, okay. Edison said, oh, I was joking. So Tesla got angry. He went on his own. He got together with Westinghouse. Westinghouse built Tesla's generators up at Niagara Falls. Niagara Falls was the beginning of major electricity. So Tesla was the man. Study him. The American government took all of his records. They're slowly coming out, but if you search the web, you can find a lot of interesting things. He did power at a distance, no wires. Kind of bad now because the computers are going zit, but there's lots of things you can do. And don't say, oh, I'm a lady. You have the brain. You've been to Japanese school. I've seen my daughter's text. She's 12 years old, and it's, wow, you know, there's physics, there's chemistry. This is advanced stuff. I didn't take this until senior high school. So the Japan schools are tough. They're good. Your students know a lot. There's no reason you can't go and talk to your Kocho sensei and say, hi, I'm a retired engineer. Can I lend some assistance at a science class? You know, I was a nuclear scientist. One of my students was at Fukushima. He did the electronics. I said, what are you doing? I was retired. I just hang around the house. My wife tells me to go to English class. You guys are there. You have the power, you have the knowledge. You have the internet, you can talk to each other. You don't care what the government says. Talk to each other. Get together and say, oi, look at this. We show you how to do it. We don't need it, go for it. You can do a lot. I often wonder, since Japan is no different from anywhere else we saw on the planet, there must be a tremendous amount of mineral wealth here. But it's not being used. You have digging machines that dig you train tunnels all under Tokyo. What if you took those up into the mountains and really started taking a look at what's under those huge mountains that live behind Tokyo? Go back there. You know, land's still cheap. Take a look. See what you got. Most of it's very, very dark material. Very dark material tends to be large atoms. You may have quite a bit of mineral wealth available to you. Just never looked at it. You know, they're getting gold down in southern Japan. They had gold in Sado Island, out in Sado. And I look at Japan, and since I sell kaseki, I look at a very strange shape here. Japan has been here a long time, but we have this big circle. And I wonder if at one time in the distance past, if we didn't have an inseki hit here, a big one, it may be that this whole inside ocean, inside sea, is the crater of an inseki. Because we have gold here, and we have gold here, and gold gets pushed up out of the earth. So we may find out that right around this edge, that inseki hit hard enough to throw some of the gold up high enough that the minerals can bring it up through the onsens. So I'd love to find that one out. Haven't heard anything yet. Other than this guy, other questions? Hi.
Some correspondents from Denmark commented that Japanese government and Japanese people are too generous. Tokyo Power Corporation. What do you think about that?
Tokyo Power Corporation. When you get into dealing with large corporations, somebody's making money. But money is there just for playing with. Yeah. Really, money on the big scale is just to be used to keep everybody going and maybe to do some big projects. Too many times the government says, "Hi, arigato. What did you want?" And they build strange things. I can't prove anything, but the men who did the huge construction projects made a wonderful amount of money. Huge. Why do you have a bridge that goes across the Yokohama Bay? You know, that's a lot of money. But you now have a bridge that goes across Tokyo Bay, and it will be there for years. So really, the government's misspending of money in Japan turned out to be good. In America, they just steal it and walk away. Here, at least you're getting some nice structures. You've got a wonderful train system. You've got all kinds of roads. Kokubunji has terrible roads, but we're working on it. I have a good question. If Kokubunji is building this nice big road from Fuchu Byoen straight through Shakusho, why aren't we doing something under that road? You're losing all that area. Kokubunji always says, I have no industry, I have nothing going on here, our taxes are so high. You have a huge piece of land that is now open. You could build some nice structures under there and do all kinds of fun things. Think about it.
Yes, I think you have many experience for the nuclear power plant. So I'd like to know, you say fuel accident, first stage, meltdown. The next stage is melt through.
Correct?
If you suppose the next stage,
China syndrome.
next stage China syndrome, melt the concrete and the earth.
The reason that it's not likely is because of the shape. Some of it got left behind. Some of it got left behind. Some of it made it down 3 levels. Some of it will be left behind. You don't have enough to create a tremendous amount of heat. Where it did happen, there is a natural nuclear reactor in Africa that is like hundreds of thousands of years old. Just the uranium came in the right place at the right time and started a chain reaction, and it would heat the groundwater, evaporate everything, and then after years the water would come back and it'd go out and come back. So if it gets down below the concrete, your biggest danger is a steam explosion, not the nuclear explosion, steam, because it's on the edge of the ocean. It's all wet. You're going to go down and take something very hot and stick it into the water. So hopefully we can get it taken apart before it gets there. So you have a good design.
Okay, thank you.
This is just the electrons that couldn't stay with their protons deep in the Earth. They get left over, they wander around. And if you can collect them, then you can use it. And there are ways to do it. Get on the internet, look for free energy. A lot of the work is being done there. They're playing with magnets. Some of in India, they're starting to replace the nuclear reactors with the new style magnets. They're finding that magnetism used properly can create a tremendous amount of electricity. So I'm watching that, and that looks really, really good. But you need the rare earth metals to make your magnets. So take a look at that. If you're young and you're looking for a really good chance to make a lot of money, look at the magnets. That's an up-and-coming thing.
If it's become truly possible, it's really a wonderful thing. But at the same time, we can't be back to the ancient times, so I'm wondering.
You want to go to the ancient times? Just go to the toilet here, the old-style toilet. That was new technology 50 years ago. I hate them. You know, the last time you had to go to the bathroom, and the next guy up the river is going to the bathroom, and you're trying to wash the dishes, think about technology. And technology only builds on itself. If the one before you, if your grandparents didn't do what they did, you wouldn't have your cosmetics, your everything, your glasses. These were unheard of a couple hundred years ago. Each small change in Japan is famous for making that nice, a little bit better, here, there. Wonderful. Keep it up. It helps everybody. And don't be afraid. Oh. One of the problems of any government is they try and regulate everything. It is very difficult to start a new company in Japan. But There is the system of when a new student comes and joins the company, he is an intern. An intern, the government says he's an intern. We don't worry about his taxes. It's a way to get along for a few years. You can start a company and say, we have no employees. Here is the company, and everyone is an intern of their own choice. The interns make whatever money they can make, and it goes into their personal account. And it is looked at by the government as still being in the company. It's not taxable as income. It's there, and it's your intern money. You get to say what happens to it. If you want to take it out, no problem. Tax, 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 and you get a little bit. But if you keep it in, I think we should have this machine. I will put my money towards that machine. Anybody else? Me too, me too. Then you get 3 or 4 guys, 3 or 4 ladies, and they get a piece of equipment that didn't cost them their pocket money, which has been taxed and taxed and taxed. It's inside. They're interns. Their money is coming back to them, and they're using it intelligently. And it's older men and ladies keeping the umbrella of a company so that the interns, the new young people, can go for it. And they can say, hey, this is great. And they can put all their energy into it. Give them the chance. You have kominkans. These are wonderful places. Look at the library over there. Look at all those books. Big rooms. Where's a couple of science or engineering rooms? You have a big place over in Tachikawa, right near the train station. It's just the big roof. No walls. You've all seen it when you go to Tachikawa by bicycle. There's a big roof there. Let some of the young engineers loose. Say, here, it's just a roof. You figure out how to get electricity from the sun, and you can use it. Let them figure it out. They have brains. They'll dig into the internet. Hell, I can't go into the internet. My daughter's had a computer for 6 months. Phew, I have no idea what she's doing. She's going so fast, I can't follow her. Okay? Give those young people a chance. You guys have it doesn't take much money. Talk to your shiakusho. Say, hey, this kominkan is sitting here doing nothing. We'd like to build a little engineering clubhouse. Okay? Get a couple of machines. They're falling apart all over the place. But young guys can't buy that huge piece of steel that holds it perfectly so they can drill a hole. They need that big piece of steel. They can make the little parts. They can make those. But that monstrous piece of steel that's going to the junkyard is gone. It's out of Japan. It's back to wherever they're smelting. Take a look around. You're throwing out everything you need to get a whole bunch of little companies going. Give them the chance. Protect them from taxes. Let them have fun. Dozo, next.
When we made the posters of this lecture, and you replied that the title would be the mega shake and tsunami meltdown. And at that time, we didn't, Japanese government or Japanese journalism didn't accept the idea of the meltdown. So just we wrote down the nuclear plant accident or something like
Originally,
that. Yeah.
yes.
So
then we changed it to meltdown.
Yeah, yeah. When did you know that or the meltdown happened? Or the people in the world?
It depends on what you consider a meltdown.
Yeah, I know.
Remember, the rods are about as big as your finger. That's a plutonium rod. They're not very big. To melt down, it only has to go through a little bit of casing, and it gets loose. So that's a meltdown. When it really melts down is when that breaks off and falls to the bottom. And another one breaks off and falls to the bottom, and they lay next to each other. Then they're really happy. They're starting to get hot. Bing, 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 bing. If enough fall down and you get a little pile at the bottom, wow, it's hard to stop. That's when it starts really getting hot and melts through the steel because there's water above, hopefully, but there's no water below, and it's insulating itself. It forms itself into a nice solid lump. Steel to plutonium or uranium, nothing to do but get hot, and eventually it will burn through the steel. So when it hits the bottom, it shouldn't. I wondered about that. There's this nice round shape on the bottom. I said, that's not really what I would think. I would think I would want some kind of pyramid so that it hits, one piece goes that way, one piece goes that way, as far away as possible. So, yeah, there's some improvements. When did I know there was a meltdown?
I've been as a Frank report.
Since
You know, Frank report.
No. This is my lecture. I'm not here to listen to you. I'm sorry, but this is serious. I'm not here to listen to you. I'm here to give a lecture. Quiet.
That is center of the.
Can you have the respect to be quiet? Can you have the respect to be quiet? This is a lecture I've been asked to give, not to listen to you. Okay? Please. Okay, anyone else? Questions? Come on. Don't let me scare you. I'm just I'm a big bear. Okay? Please, go ahead.
Thank you for a wonderful lecture today. I guess you prepared a lot for today.
It was fun.
I'm thankful. And I'd like to know, it's very simple one again. When the earthquake happened,
Yes.
Probably your parents in America.
My mom is in New Jersey, right near New York City.
Yeah.
Yeah, they knew within minutes of our earthquake.
So I'd like to, what reaction came to you?
International reaction, I was offered a place to stay by 6 different people. California, my parents, my relatives in the East Coast, and some of my friends from France and Indonesia. Said, come on down here, come on over here, no problem. The one guy in France is a geologist professor, and he was really worried. And they were offering to take some of the kids out of the area. But the Japanese people take care of their own pretty much, and you've taken care of your kids really, really well. So the rest of the world knew as fast as the news could hit the airwaves, almost faster than the tsunami, certainly faster than the tsunami. But I was standing outside my little club in Tachikawa, and the 11-story building across from me was dancing. I mean, it was moving. I said, oh, that's interesting. I said, let's go over to the field. So get away from big things. If it's up there, the gravity still applies. It will fall. Get out of the way. You know, don't huddle under a building. Get out in the field. Get out in the field. Kominkan's a wonderful place. Little buildings, nothing can fall very far. Remember, acceleration. The higher it is, the faster it's going to hit you. Just get out of the way. Okay? Next question. Yes?
Since all the times, we have one proverb. Jishin, kaminari, kaji, oyaji. Number 1, earthquake. Number 2, thunders. Number 3, haja, bad haja. So,
4 what? Number 4?
We don't have.
Father.
Yeah.
Earthquake number 1, number 2, thunders. Number 3,
Kaji.
hajas.
Kaji.
雷、火事、親父でしょ。
そう
Number 3,
Fire.
bad father.
Fire.
そうなの。
Kaji.
Fire.
そうなの。
Well, mainly the father part is because they're bored. The Japanese business system says you're 60 years old, go home. You're just getting started. 60 is nothing. Everybody's living to 80 and 90. It's boring. You can only play so much Go and so much shogi and so much golf. Yeah, it's the same golf ball. There's a lot of fun. Talk to the young guys. Say, hey, you know, what do you guys want to do? I've got this building in my backyard. There's empty houses all over Kokubunji. I know of a dozen. Been sitting there since I've been here, 7 years. They're empty. Find out who the old guy is that owns it. They need it? No. Well, build a little science thing going. Get a place where you can sit and talk. Get some of the engineers talking. You know, we talk about everything else. We talk about the birds, we talk about flowers, we talk about, it's your Japan. What do you want to do about it? Don't leave it to the government. It's your government. You own it. Tell them what you want to do. Make it interesting.
The reason we are afraid of maybe what of the day we can earthquake will be happen. We don't.
No one knows. No one knows. Fukushima was a total surprise. No. Oh yes. I'm sorry. Fukushima was not a surprise. There were 7 earthquakes before it. There were 7 warning earthquakes, and they were pretty good size. So we did have a warning. And we had the warning from 2007 that said within 30 years, 99% chance earthquake in Fukushima. We thought we were ready. Surprise. That's a lot of water. It wasn't the earthquake. Earthquake did very little. It was a tsunami. I've been told that concrete, matter of fact, you told me, concrete is the least expensive building material in Japan. Build your seawalls. You built them 7 meters, not enough. And maybe make the design a little bit better. Somehow get the water to work against itself, come up and crash back at itself, something. You know, you've got all that engineering knowledge. Put it to its own, make it fight against itself. You have the stuff, you have the concrete, you have the equipment. You can do it. Next. Hi. One more.
How do you think Japanese media stance? Because of I read May 11 at New Orleans, the New York Times. It's top rank headline, you know, Fukushima, nearby Fukushima Daiichi citizens be back to their home. Headline, you know, but in Japan it's not so like that. And Japanese junk media say 911, you know, but the United States people, another country say never say 911. September 11, 911 is as like in Japan 110, emergency use, you know. So, but still used to do Japanese media 911, you know. I don't like that. You know. How do you think about the Japanese time?
When I was asked to do this lecture, it was the question of what does America think of Fukushima? So immediately I went on the internet and there was nothing. There was nothing on Yahoo. The big story on Yahoo was some new makeup they had made. It was gone. It was only less than a month. Gone. And I thought, you know, well, let's step back. 250,000 people died in Indonesia. How long did we pay attention? A week? 250,000 people died. 1 week we thought about it. Fukushima is very close, so we think more. America doesn't care. They're on to other things. You know, who's going to be the next president? Little games. It's the constant little games that they play. No, pretty much you're on your own. When there's a disaster, yes, the country helps to a certain extent. You have to be ready yourself. You know, you are yourself. It's your family, it's your kids. You know, who's prepared if the electricity completely turns off? How long could you stay at home and be safe? Do you have enough food for a month, 2 months, 3 months? The Mormons, I am not Mormon, but I do respect them in that they tell their people to be ready for a major problem for 3 months and for a long-term problem of 2 to 3 years. So do you even know what foods will last a year in their container? What can you put in the back closet for a year and know that it's safe to eat 1 year later? You know, it's your family. We saw the 7-Eleven Nothing. You go to the supermarket. Nothing. It's empty. It doesn't take much to mess things up. Give it some thought. Can you make your own electricity? You make it on your bicycle. If you had to have light, your bicycle would be a first place to get electricity. Look around. Give it some thought. Have a little tiny generator. You can run a diesel generator off of the cooking oil that you use in the kitchen. Strain it, you can use it as diesel. Learn a little bit. There's some fun stuff. Last questions. Hi.
Okay.
Certainly. That means you're smart.
Just after the earthquake occurred, many foreign media are respecting Japanese people's calmness and orderliness, and they were even surprised because there was no rampage happening at the site. But for me, it was not surprising because it's a Japanese people's character.
Bing bong.
But is it true, for example, in the USA, for example?
They run around, steal everything they can. The Americans have been taught by their television and their movie that if nobody's looking, steal it. It's very bad. We don't like it. A lot of people do not like that. It is being done on purpose. The American people who are in power keep the American people afraid of themselves. They have a very small, upper, rich portion who pays nothing. They have the middle portion who pays for everything. And they keep the poor people to keep these people scared. These people are not scared. They got guns. They got protection. These people don't have guns. They're not allowed. They're scared of these people who have nothing and have nothing to lose. And they keep that fear going so that nobody's watching what they're doing. They're stealing the money left, right, and center. But we're getting smarter. We're turning off the television, and we're starting to look at each other and talk to each other on the internet. That's why the Americans are trying to turn off the internet, because people are getting smart. The smarter you get, the better you are. Right? Anything else? Let's have some cookies. I need a drink. I will be here cleaning up. You're welcome to come and ask questions. Thank you for coming. Coming up on 4 o'clock. These have nothing to do with our talk, but it's very fun and interesting. This is Japan growing rice and making pictures in the rice fields. Sugoi moshiroi. Any of these you have any questions about, come on up, and I'd be happy to talk about them with you. Okay? Thank you very much for coming.
Thank you very much.
Thank you very much for delivering a wonderful speech for us, but a little difficult for me.
I never said it would be easy.